Yes, it is those hydrogen bonds that make water so unique. And hydrogen bonding between water molecules leads to 4 emergent properties. 4 properties emerge that make life on this planet possible. First, molecules of water are cohesive. They stick together. Second, water has the ability to moderate temperature. Third, expansion upon freezing. Solid water floats. And water is a universal solvent for polar substances. So let's look in detail at these emergent properties. First, cohesion. Water molecules, because they're polar, like to stick together. And that leads to some other properties that emerge. But first, to get a better idea of this, it might be useful to look at something that isn't polar. This is methane. Methane is a non-polar substance.
Wish I could be non-polar.
Usually a gas, but let's say this was cool enough that it was at liquid. Now the methane molecules are always in motion, right? Molecules are always in motion. But they do not attract one another like water molecules do. See how they're just kind of zipping by one another. They're not sticky. They don't have cohesion to the degree that water does. Now let's look at water. Here you can see the water with their partial charges, and the oxygens are attracted to the hydrogens. There's that hydrogen bond, and this makes water more sticky, more cohesive. And cohesion, water molecules being cohesive, leads to high surface tension. Like you can see right here. What? A spider walking on water? How does it do that? Well, high surface tension. The water molecules create a film across the surface that can support things that are more dense. Like when I drop this solid steel needle in this water, bloop, it floats. Oh my goodness, how does that happen? Well, it happens again because the water molecules are hydrogen bonding to one another, and they create a film that can support even things that are more dense, as long as they're not too large or pierce that film. In contrast, watch this. When I drop this needle, a solid steel needle, onto rubbing alcohol, bloop, it sinks, because the alcohol does not have those hydrogen bonds or high surface tension. Now let's look at the second emergent property of water, how water does a great job at moderating temperatures within ecosystems and within organisms. Because the water molecules stick together, that makes water have a high specific heat. Specific heat is the amount of energy required to move 1 gram of a substance 1 degree Celsius. And water has one of the highest specific heats of any of our everyday common substances. That means it absorbs a lot of energy before it changes temperature. Super important in regulating the temperature of the planet. Even your body is made with so much water that helps regulate your temperature. Since water absorbs so much energy before it changes temperature, that keeps temperatures from fluctuating crazy on the planet. All the water in the atmosphere, all the water in the oceans, in the lakes, they absorb a lot of the energy that comes in from the sun in particular, and that keeps temperatures relatively stable instead of going up way crazy in the day and going down really low at night. And because most organisms, like humans, are mostly water. Humans are 60% water. I mean, Bigfoot's probably also 60% water. But since water takes so much energy before it fluctuates temperature, this helps us maintain body temperature, and all organisms maintain body temperature. It's all part of our homeostasis, if you recall that cool word. Another aspect of water related to temperature regulation is evaporative cooling. Water molecules are in constant motion, like you see here. But not all the molecules have the same amount of energy. As you can see, some are moving around faster than others. The faster ones, the ones that have more kinetic energy, they will evaporate. They'll leave the rest of the molecules, break the hydrogen bonds, and since they have so much energy, they're pulling energy away from the overall average amount of energy in that bit of water, leaving cooler water behind, having a cooling effect. That's what happens when you sweat. That's what happens with this elephant spraying itself with water. The faster molecules will evaporate off the elephant's skin, leaving cooler water molecules behind. It's also the main principle behind how your air conditioner works. So the third emergent property of water is that it expands on freezing. Yes, the solid is less dense than the liquid. So the hydrogen bonds make something really unique about water, and you can kind of see it here in this cool frozen stream with the crystal-like structures of ice right there. Cool, right? Now the reason ice forms these cool crystals, or water forms these cool crystals when it forms ice, is as the water molecules are losing energy as they cool down, they rearrange themselves into an orderly pattern that forms crystals. This diagram right here shows this. On the left-hand side, you can see the water molecules are close together in the liquid state. But as the water cools down, the water molecules lose energy, they start to rearrange themselves in an orderly pattern, as you see here on the right-hand side. And you can see there are spaces between the water molecules, and that's where air can exist. So what's very weird is the liquid is more compact and more dense than the solid. And the solid actually floats on the liquid, and that's a very good thing for this planet, because that means the solid ice that freezes on a lake or a stream or a river in the winter stays up top. If it sunk down, if it was more dense, it would sink down, and then the upper region would freeze and sink down, and the upper region would freeze, and our lakes and rivers and streams would become solid ice, and everything would die. So this is a really unique property of water, that the solid is less dense than the liquid, and it is the result of those awesome hydrogen bonds. Yes. So let's look at the fourth property of water. Water is a universal solvent. Let's take salt, for example. If we put salt in water, right, if we shake it in, it will dissolve, right? And you can see it's evident here as you stir this up. Then the water becomes clear, because what happens at the molecular level, the salt is being taken apart. Remember, salt is made of ions. So here you can see sodium losing its electron to chlorine, becoming positive ion, chlorine becoming a negative ion. They're ionically bonded, but that means they're charged, and the water molecules, being polar, surround the individual sodium and chlorine ions and pull them apart. So let's take a look at what's going on at the molecular level. The partial negative charges of the oxygen are attracted to the sodium, and they surround it in a hydration sphere, or a sphere of hydration, and that's what causes it to dissolve. Chlorine too, but here you see the positive partial charges of the hydrogen surrounding the chlorine and dissolving it. A couple terms we really should know. The thing that's being dissolved, the salt in this case, is the solute. The thing that is doing the dissolving is the solvent. That's why we call water the universal solvent. It can dissolve anything that's polar, like sugars, proteins that have polar things. Water cannot dissolve nonpolar things like oil, because they're not polar and they won't mix, and water can't form the hydration sphere around it. So let's recap what we've learned. Why do water molecules stick together so much? As Justin Bieber would say, they're so polar, 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 polar. Actually, he wouldn't say that at all. I'm not sure Justin Bieber knows anything about the polarity of water molecules. The high polarity leads to hydrogen bonding, making the water molecules stick together, which leads to cohesion and things like high surface tension. And another major emergent property is that water has the ability to moderate temperatures because it has a high specific heat. Specific heat, again, is the amount of energy to move 1 gram of a substance 1 degree Celsius. And because water absorbs so much energy before it changes temperature, it helps to regulate the environment, it helps to regulate body temperature. And remember too, that idea of evaporative cooling, that water, when it evaporates, pulls a lot of heat with it and leaves cooler molecules behind, which can help cool an organism like our friendly elephant here. The third emergent property of water was that it expands upon freezing. Remember, the solid version of water is less dense than the liquid version. So we have ice floating on water, and that has implications into letting life survive on this planet underwater. And our fourth emergent property of water is that it is a universal solvent. It can dissolve basically anything that's polar, like salt that we saw, or proteins or sugars. And this is very important. For example, all the substances like calcium, potassium, sugar, proteins dissolved in your blood that can be then transported around to the rest of your body to keep you alive. No, I realize water is not Bigfoot, but hopefully you see how amazing water is, and it's way less smelly than Bigfoot would be anyways. So, thank you for watching.